Hello and welcome to the second Captain tutorial. This one we'll be setting up a custom agent, which will be a simple UFO flight model that we're going to make. So this is continuing from the previous tutorial where we set up this this example helicopter that comes with the assets. So make sure you've watched that one first if you haven't, because we'll need to be following on from there. So, this is the scene we started from last time. So, we've got the Go pathing agent that we put in the scene. We've got the layers set up on the map so that everything can be seen correctly. And the thing that we've added now is we've added this new little UFO, which is just two spheres clipped inside each other. I'm sure you can work out how it's done. Very simple. So yes, we're going to be giving this UFO its own simple little flight model, and then we're going to use the same mouse click script. We're going to be able to click around, and it will command the UFO to fly around the scene. So yeah, that's what we're going to That's what we're going to set up by the end of this tutorial. So the first step we need to do is we need to add a flight model to this UFO. So we're going to do that by adding a rigid body because we want this to have inertia. And yeah, it'll be a simple physics-based vehicle. We're gonna disable rotation, I think, because we don't really need it to spin. We could do that with animations later if we wanted to, but it doesn't really matter for this example. So then we're gonna also add a UFO flight model, I think. So we're gonna make this new script, UFO flight model. There we go, lovely. Right, so then we're gonna set up the, we're gonna edit the UFO flight model script. So we'll just open that up. Hang on. There we go. Right, so the first thing we're going to do is we're going to set up all the variables. We're going to have a rigid body, RB. We're going to have public. Let's go for vector. This will store the target velocity. There we go, lovely. Then we're going to have public, let's go for force. This will be the force that moves it to the target velocity. So in fixed update, we will do rb.add force, and then the force will just be rb.target velocity. Wait, no, target velocity minus rb.velocity. And then we'll just, we'll just times that by force. So then, when the target velocity isn't the same as the current velocity, it will just add a force to try and match that. So that's pretty simple. Let's go for private void. No, we'll make this one public. Public void set target velocity. So this is the function that will be called from our driver. And then the driver will try and set the target velocity of the UFO, and the UFO will go where it says. Obviously, I didn't really need to create a setter, because obviously this is still public, but you know. It doesn't really matter for this example. Lovely, there we go. So that's all set up now. Right, now we can set up this script. We'll assign the UFO. We'll give it like 10 force. I don't know. You might want to work out what's a nice value for that. Let's just test it real quick. Lovely. Ah, forgotten to turn off gravity. There we go. UFOs don't experience gravity, as we all know. So that'll stop it from slowly drifting downwards. There we go, lovely. Let's set a target velocity of 10 on the x-axis, and yeah, off it goes. Yeah, that seems pretty reasonable. Right, lovely. So, the next step, we're going to be making a UFO driver. So we're going to do UFO underscore scope driver. Right, so we're going to want this to derive from, we're going to need to import using cheese, which is my namespace, gope, which is the namespace of the asset, and then we're going to have, it's just gope. There we go, lovely. Then we can go, I think gope driver? Yes, lovely. Right, so then we just need to override a bunch of things. So we got get current state. Pretty much all of these I think are necessary to override. So get current state, pretty simple. We'll just return, I think we can do new Goat World State Vehicle, and we can just pass our rigid body as the thing. So we'll have a reference to our UFO flight model. UFO. Lovely. We'll just pass the rigid body because it already has a nice constructor that will get the velocity and the position out, and it'll be able to pass that on to the rest of the driver. Override. What else we got? Get request. Right, so the next one we're setting up is get request. So we're going to need to use cheese.goapp.aircraft because that will give us the new Goat request simple aircraft, which is what we'll be using. So let's just check the constructor arguments. So we have to pass a Goat agent, which is this, because Goat driver derives from Goat agent. We need a goal. So we'll just go, can we use the default goal? I think we can use the default move goal. So let's just say default move goal. Lovely. Sim step time. That will be, let's make that, oh wait, I think that's also, yeah, that's also in the base thing. Vehicle specs, I think, yeah, so that already comes with vehicle specs. These are all things that come from the Goat driver. So I think the only thing left we need to do is we need public aircraft specs, simple aircraft specs. So yeah, we'll call that aircraft specs, and then we can pass that as an argument. So what's wrong with this? Step time, there we go, lovely. So yeah, there we go, that's the request. So what will happen is when the Goat driver needs the path request, it'll call this function and it will return this, and that gives it all the information it needs. So it'll be using the default move goal. So we could override this if we could change this if we wanted to use a different goal. But the default move goal, because it's just a move command, that's what we want. Don't forget the semicolon. What's next? Override. Get velocity. That one's very easy because we can just do UFO.RB.velocity. This is used so that the driver knows how fast it's going because it needs to be able to obviously control itself. What's next? Override is alive. Well, in this case, our agent cannot die, so this will always be true. If you had something that had health and could die and could be destroyed, then obviously you wouldn't want to waste time creating paths for it, so you could return false if that was the case. Also, if it's null, it won't generate a path. So if this agent is destroyed by the game, then it doesn't matter. It won't waste time processing it. So next thing is move velocity. So yeah, this one's pretty simple. What this is this the driver will call this function and it'll tell us to move at a certain velocity, so it'll tell our UFO. So we need to pass this on to the UFO flight model. UFO dot target velocity, what do I call the function? Set target velocity, there we go, very simple. Velocity, lovely. Then we have terminal navigate. So once you've reached the end of the path, you might want a nice parking behavior. So you can very precisely line it up. I'm not super bothered by that for this test, so we're just going to set it to move velocity vector 3.0, and this will just tell it to come to a complete stop when it's in a certain radius of the target, which you can customize on the Goat driver itself. Then override, I think this is the last one, panic. So sometimes what will happen is the Goat driver, the goal action ordering planning system, it won't be able to come up with a path, which is very unfortunate, but it won't be able to. This can happen usually if it's clipping inside of something. So for example, if your agent has a radius of say 10 meters and there's a wall inside of 10 meters, it'll see that as soon as it starts, it'll collide with this wall and it thinks it will die from that. So what you usually want to do is you want to come up with some simple behavior that'll like escape it from this. We could just get it to move up. That would probably work on this map because it's very simple, but you know, you might want to try using raycasts in case there's an obstacle above you, but in this case I think this should be good enough. Probably we want to be a bit faster though. There we go, lovely. Right, so if we come back to the Unity editor, we can see our GOP driver is now here. So lots of these come from the default GOP driver, and then these are all the variables down here that we've added by overriding. So we can assign the UFO flight model, and we can also assign the specs. So I'm not sure how fast a UFO can accelerate. Let's say 5 meters per second. I think these shouldn't matter because our map isn't high enough that it'll ever reach these limits. Max descent rate, max climb rate, yeah, that seems fairly reasonable. Vehicle specs, what do we got? Max speed, I think our UFO can go a little bit faster. 5, how big is our UFO? Let's check the collider. 0.5. Okay, so it's like 10 meters. It seems like it's 10 meters across. So I think it's 5 meters to here, but we'll give it some extra like wiggle room because obviously it's physics-based, so it's not going to follow the path exactly. So we'll say its radius is 10, and it will collide with default, and it will collide with the terrain. It won't collide with other regions. So it doesn't have a minimum speed because it's allowed to come to a stop. So let's say it can go at 30 meters per second. Yeah, that sounds good. So yeah, step time, we need to assign that. That's going to be 1 second, so it'll look into the future in 1 second steps. Terminal navigation radius. So when it's within 5 meters of its goal, it will use the terminal navigation function, which in this case has just come to a stop. You could park it precisely if that's what you wanted to do. Transform, that'll be the transform of the thing. Right, so because I don't want to make a new goal, we're just going to use one of the helicopter goals, I think. What's this one? Move to orbit, move to position attack helicopter. So yeah, we're going to use the attack helicopter one, and this means we'll get to use the same terrain following behavior the attack helicopters have, so that's quite nice. Maximum path deviation. So this is if it comes like 20 meters away from its path, it seems that it's gone too far away from the path, and it'll have to generate a new one, because obviously if it's physics based, you know how the physics engine is, it'll probably chuck your vehicle really far at some point. So when it goes too far away, it'll say, we need to come up with a new path, and that's what this variable's for. So I think 10 meters should be good enough, because that's about how far we set the collision radius. It seems unlikely that we'll stray more than that from the path. Generation cooldown is how frequently it's allowed to call the pathfinding algorithm in seconds. So once it generates a path, it must wait at least 1 more second before generating a path. And this is to stop it from generating a bunch of useless paths that are more or less exactly the same, if for some reason it's very unhappy. So path lead time, this is how far ahead along the path it leads it. So if it has a path and it needs to go at 10 meters per second, it'll be looking 1 second ahead, so it'll be steering at a point 10 meters ahead of the path. So you can adjust this, so if it's too small, it'll probably keep oscillating, and if it's too big, it won't steer fast enough to the curve, so you can adjust that to get to how you want. Minimum lead distance, this is just in meters, so it'll always look 1 meter ahead along the path it's following, if we're imagining a path here. Crawl speed is the minimum speed it can travel at while following a path. This is just to avoid it getting stuck. So if the path says go at 0 meters per second for whatever reason, which sometimes it can, it'll actually travel at this minimum speed instead. So that just prevents it from getting stuck. And then step time, yeah, that's how many times it looks at it. And then end path acceleration. So it can only look so far into the future, right? So it'll only see like, I can only see however many steps in the future, let's say 10. As it reaches the end of the path, if it keeps traveling at top speed, it would eventually fly off the end of the path if the algorithm didn't generate a new path in time. So what this does instead is, as it approaches the end of the path, it will slow down at 3 meters per second. So if it ever does reach the end of the path, it'll come to a nice stop, and it won't crash into things at high speed without a path, because that's very reckless of it. So that should be everything. We just need to go to the main camera, assign the Go driver to our new UFO, and with a bit of luck, it'll work first try. Wait, let's turn on the gizmos. Can we see what it's doing? That's no good. It's climbing up. I bet that's the panic behavior kicking in. So basically, for whatever reason, yeah, there we go, it's on the wrong layer. It needs to be on the agent layer. So as I mentioned earlier, this is what panic behavior is before. So when it asked the pathfinding thing for path, and it said look for a path to our goal, it saw itself because it was on the wrong layer. and it saw itself as an obstacle. So because of that, it was like, I need to stop clipping inside of this obstacle. So it was calling the panic function, and it was moving up at 10 meters per second to try and get out of the obstacle. So obviously, if the obstacle was the terrain, moving up would have been a good idea, but because the obstacle was itself, it would just keep climbing forever. So now that we put it on the correct layer, it shouldn't see itself as an obstacle, and it'll only activate that panic behavior if it gets too close to the terrain, which it shouldn't, but we'll find out. Oh, what have I done now? Right, I found the issue. So the problem is that instead of using the matching Gulp World State simple aircraft, we were using simple vehicle. We were just using the base vehicle one, which doesn't actually have any movement types. It only has a velocity and position. So basically, it wasn't doing anything after a single state. That was my problem. Oops. Right, so if we go now, it should have all the actions a simple aircraft has, which is to move in any direction at 5 meters per second. And you can see, off it goes. Beautiful. So yeah, it has the same goal as the helicopters, so it's still doing the terrain following behavior. And you can see it's avoiding obstacles such as this nice hoop and these little cubes. So if we move the camera, we follow it around, and yeah, you can see it'll nicely avoid obstacles and fly through the terrain. Very nice. So yes, you can pretty much use this technique to create any type of flying agent, so, or even like an underwater agent if you really wanted to. And yeah, you can use this system to create all sorts of interesting AI agents, flying AI agents for your games. Anyways, thank you for watching the second Captain tutorial. I'll probably make some more in the future of these, probably explaining how to make like new custom goals and how to set up goals and stuff like that. But yeah, it should be good for getting started in the meanwhile.